Well, hey there, this is Mrs. Sharp, and this is a short video set of notes on Learning Target 4.5. Basically, you can think of Learning Target 4.5 as kind of a history of the periodic table. Our goal is to explain how the periodic table changed as it was developed, and to understand how early thinkers like John Newlands originally organized the table, how this changed with Mendeleev's table, and how Henry Moseley finally organized it into the modern arrangement we now know it as. This would be in section 6.1 of the book. So let's talk about how the periodic table was developed. John Newlands, in 1864, when about 60 elements were known, proposed what's known as the law of octaves, and he arranged elements by increasing atomic mass. So that average mass of one atom in AMU, he started with the very lightest, and he arranged them from lightest to heaviest. What he noticed is that about every eighth element, the properties of the elements repeated themselves, meaning the element in spot number 1 would have properties very much like the one 8 later. And so he called this the law of octaves, because an octave in music is 8, a separation of 8. Poor John Newlands was discredited because it didn't really work for all the elements that were known, and because he made the mistake of mixing music with science. Back then, that was a big no-no. John Newlands was discredited, but he came up with some pretty interesting ideas about these repeating properties of the elements. And just because it didn't work every 8th element necessarily doesn't mean that he wasn't on to something. Okay, in 1869, we knew about 70 elements, so this is just a short time later. This is the work of Lothar Meyer and Dmitri Mendeleev. They were working separately. Lothar Meyer was in England and Dmitri Mendeleev was in Russia. And they also arranged elements in order of increasing atomic mass. So it was the same basic premise as what John Newlands did. An interesting twist is that they put elements with similar properties into columns, and brilliantly, if something didn't fit in a column, instead of forcing it there, kind of like John Newlands did and seeing that it didn't work, they left blank spots, instead proposing that just because there wasn't an element there yet, there would be, it just wasn't discovered yet. Pretty brave and pretty interesting. Dmitri Mendeleev is one of the creepiest scientists, in my opinion, but he was very smart. This is a replica of Mendeleev's original periodic table. You can see here up in the top that everything's written in the Russian alphabet because he was a Russian gentleman. And if you look at this chart, his columns were not what we think of as columns. It's kind of flipped on its side. So for example, right here you've got lithium with a mass of 7, and then sodium, potassium, rubidium, cesium, and that column is actually what we would think of as a row. So you kind of flipped it on its side. And then the second period, I'm going to use blue for that. You can see the beginnings of the second period right there. So it's just kind of as though the periodic table was flipped, like rotated to the left. But he proposed these columns where elements with similar properties all were together. Interestingly, these question marks here, he proposed that those spots would be filled by undiscovered elements. And so that one right there, that question mark, is he proposed would have a mass of 180, and later that was actually found. It was found to be the element hafnium. Same thing you can see in here, a couple question marks where he thought things would go. And then he has some other question marks here by the mass, because those masses weren't quite 100% determined or accurate yet. Mendeleev is generally known as the father of the periodic table because of his work. right, so we have Mendeleev here in the middle in his cap, and then he is also on the left, and Lothar Meyer, who doesn't get nearly as much press, even though he did the same basic work. Mendeleev is the one who's called the father of the periodic table. Lothar Meyer's there on the right. So a while passes. We were 1869. We get to 1913 and Henry Moseley. And Henry Moseley mixed it up a little bit. Instead of organizing the periodic table by increasing atomic mass, he kind of threw that out the window, and instead he arranged the elements in order of increasing atomic number, which would be number of protons. So because of the issues that Mendeleev and Meyer and Newlands had with the mass not quite working perfectly for everything, Moseley ditched that and tried atomic number instead. And when he did that, that seemed to be the magical ingredient for putting the periodic table together. Once he did that, he was easily able to form what's known as the periodic law. And the periodic law is this: when elements are arranged in order of increasing atomic number, there is a periodic repetition of properties. Now, periodic means once in a while, and that was the brilliance of Henry Moseley. When he arranged by atomic number instead of mass, he didn't propose a specific number of elements that would have to pass for those properties to repeat. Instead of a specific number like 8 in the law of octaves, he just said a periodic repetition of properties. If you think of what like periodically means, like if I assign homework periodically, that's just every once in a while. So it's very vague. And that was the genius of what Moseley did, is that by not putting a specific number on that, he was able to show that the properties repeated themselves, but he wasn't discredited for saying a certain number that may or may not be true. So that's where periodic table comes from, is that those properties repeat periodically. Every now and then, once in a while, there will be an element that acts very similar to another element, and those elements are grouped in families. Oh, there's another picture of Mr. Moseley there. And he is not known as the father of the periodic table, even though the periodic table we now know and see is because of his work. Okay, and that's it for now. Thanks for watching, and I'll see you soon.